So this is an area perimeter and volume question, and the interesting thing about this is it's not a formula that we would be familiar with, the volume of a cap. A cap being when you take a sphere and you cut off a flat surface off the top of it, the volume of that piece that you've cut off, that's the volume of the cap. We wouldn't be given this formula, or we wouldn't have used it in previous exam papers or over the course of your study of maths in higher level. You probably haven't seen this formula. It's been derived by other mathematicians, just like the other formulas that were used to have been derived. So somebody derived a formula for the volume of a sphere, 4 over 3 pi r cubed. I think Archimedes might have been the first one to come up with that. Somebody then very easily said, well, a hemisphere is half that, so 2/3 pi r cubed. And here we have a formula for the volume of a cap that, again, other mathematicians have derived using these formulas. So in this question, this initial version of the question, we've been told that r is 13, so the radius of this particular sphere is 13. Now we're not given the units, whether it's centimeters or meters or whatever it is, so we're just going to use the word units when we're not sure. And then the vertical height of this cap is 4, so k is equal to 4 units. And all we're going to do for this first part is we're going to feed those two dimensions into the formula for the cap. C is equal to pi times k squared over 3 on 3r minus k. So r is equal to 13, k is equal to 4. We put them into the formula. You can manually do some of this, but there's nothing wrong with throwing this all into the calculator and getting your answer. Your answer ends up being 560 pi over 3. But if you were to do a little bit of it manually, first 3 by 13 is 39, and then 39 minus 4 is 35, and 35 by 16 is 560. Make sure to leave the pi in the answer. Always go back and read the question again. This question says give your answer in terms of pi, as opposed to give your answer to a certain number of decimal places. So the volume of this cap, of vertical height 4, of a sphere of radius 13 is 560 pi over 3, and then units cubed. Again, sometimes in my solutions I don't put the units cubed up here. You would lose marks in the exam for not specifying that the units, its volume, so that it needs to be cubed, but I normally put them in a box in a line afterwards. Okay, the second part of the question then, we have a different sphere. It has a different size, so the radius of this sphere is 8 units, and we're not told the vertical height of the cap, so they tell us that it's y, but we don't know exactly what that is. The second part of this question, B part 2, it asks us to actually solve an equation and find y, but we would need to be given other information, and the other information we're given is that the volume of that particular cap is 36 pi y units cubed. So what we're going to do is we're going to take our formula, we're going to write down our given dimensions. So our given dimensions are that r is equal to 8, k is equal to y, and then the volume, c, is equal to 36 pi y. So feed them into the formula. 3 times 8 is 24, so that's probably the only first bit of tidying up you can do. And then we always, if they've asked you to show something, so they've asked us to show this box up here, that y over 3 on 24 minus y is equal to 36. If they've asked us to show that, we need to kind of pause for a second and see, like, how are we going to do that? Well, there's no pi's in this, so I can see a pi here. I'm going to divide both sides by pi to remove the pi, and I can also see a y on both sides. So what I'm actually going to do is I'm going to divide both sides of this equation by pi y, and I get 36 is equal to y over 3 on 24 minus y. Now that is what we're looking for. Okay, it's written in reverse, but I'm just going to switch it around. If two things are equal to each other, then it doesn't matter the order that you write them. And so y over 3 on 24 minus y is equal to 36. Okay, so what's left here is to actually solve this equation. We want to actually find the value for y for which this cap has a volume of 36 pi y units cubed for a sphere that has a radius of 8. So if we write down the equation, it can be solved a number of ways. I think what I'd be inclined to do is to get rid of the fractions first. So I would multiply both sides by 3. So I get y on 24 minus y is equal to 36 by 3 is 108. I'd multiply this out to give me 24y minus y squared equals 108. It's more closely resembling a quadratic now. If I was doing it another way, I could have said y over 3 by 24 is 8y, and then y over 3 times minus y is minus y squared over 3. That's equal to 36, and then multiplied across by 3. So you get the same point in the equation. And then I'm going to multiply by -1 and collect all the terms on the left, just to have a quadratic that starts with a plus. So y squared minus 24y plus 108. You can use the minus b formula on this, but this is easily factorizable. So if we do y minus 18 on y minus 6 equals 0, we let each bracket equal 0 to solve the quadratic. So y is equal to 18, and then y is equal to 6. Now you'll see I coloured y equals 18 in red, and I've written down underneath that this isn't a valid solution. Y can't be 18, and the reason it can't be 18 is if we go back to our sketch, the radius here is only 8, so it doesn't make sense for the vertical height of the cap to be something like 18. Well, actually 18 would actually go down underneath the sphere because the diameter of this sphere is 16. So y equals 6 is the only valid solution to this question. And what is y equals 6? Y equals 6 is the vertical height of a cap on a sphere of radius 8 that has a volume of 36 pi y. Okay, so similarly, we have a formula in this C part that has been derived that we generally don't see. Like, this is the formula for the volume of a hemisphere. So let's just draw our hemisphere. But this formula is a function of x, where x is the diameter. So the volume is based, in this case, off the diameter. We're used to seeing the formula for the volume of a hemisphere as 2/3 pi and then r cubed, where the volume is a function, let's say, of the radius. So here the volume is a function of x being the diameter. So it's not a big leap to actually derive this ourselves, and I thought it might be a good idea just to explore that for a second, and not with this formula, but with the formula that we've been given for a cap. So if we have a look at the formula for the volume of a cap again, we can think of a cap where the k value, the vertical height, is equal to the radius. That would give us a cap that's equal in volume, let's say, to the volume of a hemisphere of radius r. So let's go and do that. Let's set a k value equal to r and put it into this formula for the volume of a cap, derive the formula for the volume of a hemisphere, and then see how we can actually derive this formula, which is in terms of x. So let's start with c is equal to pi times k squared over 3 on 3r minus k. So we're setting our k value to be the radius of the sphere. So c is equal to pi times capital R squared over 3 on 3r minus r. And then we say that the volume of the cap is equal to pi times r squared over 3 times 2r. And that's equal to a volume of 2/3 pi times r cubed, which is the formula for the volume of a hemisphere in terms of r being the radius. Now, how do we jump from that to the formula that we've been given? So what we're going to do is we're going to have a look at the relationship between the diameter and the radius. So clearly, if the diameter is x, that's equal to twice the radius. And if we write the radius in terms of x, we say that the radius is equal to x over 2. So the radius is equal to half the diameter. So we change this formula. So c is equal to 2/3 times pi. And instead of the radius cubed, it's going to be times x over 2 cubed, which is the radius, but now it's in terms of x. So the volume is equal to 2/3 pi times x over 2 cubed is x cubed over 8, and that's going to be 2 over 24 pi times x cubed. And then if we divide the top and the bottom by 2, we get pi over 12 x cubed. So that's how they've come up with this formula for the volume of a hemisphere in terms of its diameter rather than in terms of its radius. And I think it's important sometimes to pause and have a look at stuff like that, because this formula would have thrown people look at it and it's a little unusual. Now, actually solving this question is quite easy. There's 15 marks for that, and it's fairly straightforward. All we're going to do is we're going to let this volume formula equal 3 liters, and we're going to solve for the value of x. Now, we have to be careful here in terms of our formula for the volume here is for the volume of a hemisphere in centimeters cubed. So if we've been given the formula for the volume in terms of litres, we need to convert that litres to centimetre cubed. So 1 litre is 1,000 centimetre cubed, and so we have 3 litres, that's equal to 3,000 centimetres cubed. So we're going to let our formula, pi over 12 x cubed, equal 3,000 and solve for x, the diameter. So pi over 12 x cubed equals 3,000, so divide both sides by pi over 12, and we get that x cubed is equal to 3,000 divided by pi over 12. So x cubed is equal to 36,000 over pi. Now, obviously I've thrown that into the calculator, but a quick way to look at this is if you want, you could say that to divide by a fraction, we flip the fraction and multiply it. And 3,000 by 12 is 36,000, and then we're dividing by the pi. So x cubed is equal to 36,000 over pi. So x is going to be the cubed root of 36,000 over pi. And then obviously we're going to have to throw that into the calculator, and we get 22.545. And then always read the question carefully again. This says give your answer in terms of 1 decimal place. And so x is equal to 22.5 centimeters.